Okay, we are starting video number 3, and I am starting with problem number 8. Number 8 asks us to find dy dx for the pieces y equals the natural log of the absolute value of u, and u equals x cubed plus e to the x. If you recall, I have taught 2 different ways to do this type of problem. One a little bit longer ago and one a little bit more recently. So I think on problem number 8, I'm going to show both options, and that way you have an idea of what your options are. Really, which option you use depends on you, and it also depends on the difficulty level of the problem. So if you look at the paper answer key, like my handwritten out answer key, the first option I show is just going ahead and combining and going ahead and substituting that u in and making this just a y equals equation in terms of x. And so that's what I'm going to do here, is I'm going to go ahead and substitute my u value in and say y equals the natural log of the absolute value of x cubed plus e to the x. And now, since we're asked to find dy dx, and I have a y equation defined in terms of x, I can just take the derivative using basic rules here. So the derivative of y is dy dx. And then you have to ask yourself, what is the derivative of the natural log of something? And the derivative of the natural log of something is 1 over something. So in this case, 1 over my something, which is x cubed plus e to the x. And then you can't forget that we then have to multiply by the derivative of something. So the derivative of x cubed plus e to the x. Derivative of x cubed is 3x squared, plus derivative of e to the x is e to the x. At this point, it's just some basic cleanup. And since the first one is a fraction, the second one is just an expression that can be put over 1. I can multiply this into one fraction and say 3x squared plus e to the x all over x cubed plus e to the x. That is one option for completing this problem. That is about as far as I can go with this problem. Note, we can't cancel the e to the x's, we can't cancel x's because they are added to other terms. So we'd have to cancel a factor there. Now, as I said, in this particular problem, I think I am going to go ahead and show the other option of how we can do this. And that would be where we go ahead and find each of the derivatives individually of each of the pieces and then combine them. So as we look at the first piece, y equals the natural log of the absolute value of u. Take the derivative, since this is y equation defined in terms of u. When you take this derivative, you'll be doing dy du. And so the derivative of the natural log of u is going to be 1 over u. We can also do the same thing with the other piece that's defined, which is u equals x cubed plus e to the x. In this case, it's a u equals equation defined in terms of x. So it's going to be the derivative of u with respect to x. So du dx, derivative of x cubed plus e to the x is 3x squared plus e to the x. Now, keep in mind, they asked us to find dy dx. And if you notice, they asked us to find dy dx. Well, the pieces we just found were dy du and du dx. So if you take those two pieces and multiply them together, the du's cancel, and we'll have dy over dx. So let's fill in what we know. Dy du we found to be 1 over u. du dx, we found to be 3x squared plus e to the x. Now keep in mind we were asked to find dy dx, so our answer all needs to be in terms of x, and we currently have a u in the works. And so we need to take this u value and replace it. And if you recall from up above, u is defined from up above. And so we can use that information to replace it. So dy dx is, instead of 1 over u, it's 1 over x cubed plus e to the x. Still multiplying by 3x squared plus e to the x. And as we put this together, you will notice it is similar to what we did on the left side of the screen, whereas this multiplies to be one fraction with 3x squared plus e to the x over x cubed plus e to the x. Okay. Both are valid options. In this case, as long as you catch the chain rule at the beginning, the first option probably works just as easy. I will tell you that when we get to number 10, we're going to be dealing with similar issues. Okay, so number 10 is a little bit, the difficulty level I feel like is a little bit higher though. But for right now, I keep trying to stay in order so you can find what you need if you want it. And that means we're going to look at number 9. Number 9 asks us to find f prime of 2. So that would be finding the derivative of f evaluated at 2. Now, I am looking for an exact answer, not a decimal answer. And so since we are finding the exact answer, we will need to work it out by hand. So, f prime of x. First, and probably most important thing you need to notice, is that as we look at this, f prime of x, the function is natural log of x times the trinomial x cubed minus 5x plus 2. Hugely important. There are two factors being multiplied together. This means we need to apply the product rule. If you recall the product rule, the derivative of the first times the second plus derivative of the second times the first. So let's do that. The derivative of natural log of x is 1 over x times x cubed minus 5x plus 2. So keeping the second part of the function as is. Product rule says plus, and now we're going to reverse what we just did. So we're going to keep the natural log of x, and we're going to multiply by the derivative of that trinomial. Derivative of x cubed minus 5x plus 2 is going to be 3x squared minus 5. At some point you have to plug the 2 in. I'm personally going to do a little cleanup before I plug the 2 in. You could go ahead and plug the 2 in and do it that way as well. The cleanup I'm focusing on is really at the front here, that when I multiply by 1 over x, that will clean up a little bit, so I can distribute the 1 over x. 1 over x times x cubed is x squared, minus 5 over x times x is just 5, plus 1 over x times 2 is going to be 2 over x. I'm also going to go ahead and distribute in the second part. And again, maybe I don't want to distribute there. Well, I'm going to go ahead and distribute. So it's the natural log of x times 3x squared. So 3x squared, natural log of x, and then minus 5 times the natural log of x. Since we are asked to find f prime of 2, I now need to take this and plug in 2 every place I see an x. So 2 squared minus 5 plus 2 over 2 plus 3 times 2 squared times natural log of 2 minus 5 times natural log of 2. From here, there's just a bunch of cleanup that can happen. 2 squared is 4 minus 5 plus 2 over 2 is 1 plus 3 times 2 squared, so 3 times 4, that's going to be 12 natural log of 2 minus 5 natural log of 2. I see one more cleanup step, and that is just putting like terms together. 4 minus 5 is negative 1, plus 1 is 0. My constants cancel out. So then it's 12 natural log of 2 minus 5 natural log of 2, which will result in 7 natural log of 2. And that's how I'm going to leave it. Okay. Yes, there would be a decimal equivalency, but that's not what I'm going to be looking for. Moving on. And we're going to try number 10. Sorry, I'm looking at the paper and realizing this is a bad one to have a hole in the middle of the work paper. Oh well, we will make it work, won't we? I am kind of debating which way I want to do this, or if I should do this one both ways as well. Again, as I said, this one just has a little bit higher difficulty level. So, if I start on the left side of my screen again, and one option, and this is the option shown on the front of the review worksheet, and that is they're giving me G, they're giving me F, and they're asking dg of dH, so I could go ahead and fill F into the G equation and get an equation that is G in terms of H. And so I'm going to do that. So G equals 5e to the F, except the F is natural log of H over 2H. Now we're asked to find dg/dH, which we can find directly at this point because we have a equation G defined in terms of H. So as I go to find dg/dH, we're being asked to do the derivative of 5e to some power. And the derivative of 5e to some power is 5e to some power times the derivative of some power. And that's where this one gets a little dicey, because we're now doing the derivative of this fraction, natural log of H over 2H, which means I need to use my quotient rule in that fraction. So the derivative of natural log of H, so 1 over H, times the denominator, 2H, minus derivative of the denominator, so 2, times my numerator, natural log of H, all over denominator squared, which is going to be the quantity 2H squared. As I continue along, basically from here, it's doing some cleanup within that quotient rule. I am going to jump down here, so I hopefully do not get caught in that spot. You won't be able to read. So dg/dH, 5e to the natural log of H over 2H times, and the cleanup I can do in that fraction, 1 over H times 2H is going to be 2, minus 2 natural log of h. The quantity 2h, when I square it, becomes 4h squared. And so I see one last bit of cleanup. So dg dh is 5e to the natural log of h divided by 2h times, and if you notice, all pieces in that fraction can divide by 2. My numerator has 2 terms, they both divide by 2, and my denominator has a 4 that divides by 2. So if I divide everybody by 2, it becomes 1 minus the natural log of h divided by 2h squared. And that is probably about the best way to express my answer. Now, hopefully I have room here, because I am going to go through the other option, and I guess you guys have the power over this video. So if you don't like or want to see me go through the other option, then you don't have to watch it, right? Okay, so the other option is to go ahead and take each derivative individually and then put them together in the end. Meaning, if I start with g equals 5e to the f, this is a g equation defined in terms of f. So that means when I take the derivative, I'm finding dg df. And the derivative of 5e to the f remains 5e to the f. For the other equation, f equals natural log of h over 2h. This is an f equation defined in terms of h. So that means when I take the derivative, I'm finding df dh. Notice this is a fraction, so we are employing the quotient rule. Derivative of the numerator, so 1 over h times the denominator, minus derivative of the denominator, which is 2, times the numerator, natural log of h, all over denominator squared, which is the quantity 2h squared. As of before, we need to do some cleanup. So df dh, 1 over h times 2h, is going to be 2, minus 2 natural log of h, all divided by 4h squared. We multiply that out. There is a factor of 2 that can cancel out of everything. Whoops. So df dh becomes 1 minus natural log of h over 2h squared. Now, since we are trying to find dg dh is what we're asked to find, keep in mind that can be found by doing dg times df and df times dh. Notice the df's will cancel, and those are both the pieces we found. So put this together, and dg dh is equal to dg df, which was 5e to the f, times df dh, which was the 1 minus natural log of h divided by 2h squared. Keep in mind, the one thing that is important here is that we cannot leave an f in our answer, but f was defined above, and so we can substitute that value in. So final answer, dg dh is 5e to the, what was f? Natural log of h over 2h times the df dh we already have, which is 1 minus natural log of h over 2h squared. Yes, both answers come up to be the same. And so hopefully that is good. Okay, I'm going to stop this video here, and 11 and 12 will have their own video.